Contracts are in place.
Okay, hey, let's walk through some stuff here. All right, trig functions. Let's go through the basic ones. Sine, cosine, and tangent. Yep. Sine, cosine, and tangent. These are the basic forms. Now, they also have a reciprocal. That means you can flip the answers over. We'll talk about it here in a minute. These are the basic ones. I've already heard the little acronym we have. So, So, oh yeah, I'm not supposed to. All right. All right.
Can I erase this?
Do you want to bring those out while I'm writing off the size out and go get
I
it?
can't bring it up.
Or do you already have it?
All right. So, on SOHCAHTOA. Hey, let's stop talking, please. So, on SOHCAHTOA, what we're going to be talking about is how to actually calculate with the trig functions.
They repeated the same number.
You look so angry.
I'm kind of mad now.
Hey, Mr. Ward, come here.
It's a joke. You can leave. I don't care anymore.
Okay.
So, here to teach. Joke around, get out. So, sine. You have sine, cosine, tangent. Sine, the trig function itself. You have sine of an angle. So we use the actual Greek letters, theta, betas, alphas. Then what these stand for is the second letter goes on the top, third letter goes on the bottom. So that's why it's O and H. Opposite and hypotenuse. That applies to a right triangle. Remember, the trig functions, the most common mistake people make is they forget it only applies to right triangles. That's it. That's what it's supposed to apply to. There is a way to manipulate what they call oblique triangles, triangles that are not right, into right triangles, and they can use the trig functions. That's called the law of sine, law of cosines. We talked about that last year. Those are the later sections we used. But the idea is that the trig functions are still important. The main thing is not only are just how to find on a right triangle like values for the missing numbers, but also how to type it in, how to look at the actual graphs in like radian measure. So we're going to talk about that here in a second. But remember, what sine actually stands for, it stands for the opposite wall. So if you have an angle in the triangle, it stands for the opposite wall, and it stands for the hypotenuse. That's what sine stands for. Now, the other wall that's on this triangle is the adjacent. We'll write it down a little bit ago. The adjacent wall is used on these other ones, the other trig functions that have an A in it. So like cosine of an angle stands for adjacent and hypotenuse. So that's what A and H stand for. The last one, tangent, stands for tangent of an angle is opposite over adjacent. Okay, these are basic three. Most people know how to use them, they know how to solve for them. The only difference I want you to know, so if you have your special triangles, so we're going to go with the 30, 60, 90 triangle. 30, 60, 90 refer to the angles in a triangle. The side opposite of 30 is the number 1, the side opposite of 60 is root 3, the side opposite of 90 is 2. And it can be any multiple of those. So what I mean by that is it doesn't have to be 1, root 3, and 2. It could be 10 feet, 10 root 2 feet, and 20 feet. Because you can just multiply all the numbers by 10.
Isn't there root 3?
10 root 3? Yeah. So, but yeah, so it can be any manipulation of it. But the idea is that what these are used for, pretty much the special triangles, they're used for A-frames on houses. When they build a roof line, they're in either a 45, 45, 90 triangle, or they're going to be in 30, 60, 90. That's what they build them in. Unless you have a flat roof, I guess. But the idea is that most housing will use those default ones, and then they'll manipulate them. They can mix two together. Just depends on the layout of the house. It depends on like.
How about 45s?
45s, yeah, you can have that if it's very symmetrical. Older houses usually have 45s. Everything was very square, cubish. All right, but when we actually solve a trig function, these, like, if they ever want you to find theta, find an angle, the angle would be missing. If you at least have the walls, you can go find it, or at least one or two of the walls. That's something that we were talking about a lot last year, that if they gave you the numbers in these spots, you can go ahead and find the wall length. So maybe this is a 1, a 7, and this happens to be a 6. And that has to be true. The third wall always has to be less than the other two put together.
Your
Let's make
hypotenuse wasn't
yeah.
the biggest
Let's
wall.
go. Let's go. This is 7 and
4.
3, 6,
no, it's gotta be
2,
it's gotta be like
1.
9.
4.5.
8.
6.6. Okay. The hypotenuse should be the big wall, but I'm saying that it should be less than it should always be less. The hypotenuse should always be less than the other two put together.
So that's
Okay.
not, that doesn't work.
Yeah, when you add these two, that's 7.6.
That's bigger than
That's bigger than the hypotenuse.
Oh,
Okay.
I
Now,
thought they had to be less than the hypotenuse.
no. These numbers by themselves have to be less, but when you add them, they have to be more.
When you
Oh.
go
So
around
there's
the
like a
block,
stipulation.
it's
Now,
gonna be short.
if I want to find an angle, you can pick any of the trig functions up here. I'm going to pick tangent.
Can I figure out what that wall's actually gonna be?
What do you mean?
Is it gonna be the ABC for me?
Okay. All right. But anyway, you have your tangent. This is going to stand for the opposite wall over the adjacent wall. So 6.6 divided by 1. Now, how do you solve for angles? If you're missing an angle in a right triangle, you can take the inverse trig functions, which are these. This is the most common misconception people have with this stuff, is that they don't know what those trig functions are. They have that misconception with like the -1 means. It means that you're finding the angle. It's also known in college level textbooks, which your book is, it actually calls it arctangent. And that's new. That's something we need to bring up. I'm just gonna write 6.6.
That's the elephant in the
6.6.
room.
Yeah, that's the thing that they don't tell you. Arctangent is the inverse tangent key. Some calculators actually have that. Casios versus Texas Instruments. Sometimes they had them labeled differently. Nowadays, it's kind of uniform. They just expect it.
So arc is the inverse?
Arc is the inverse. So you're finding the angle.
Is it only with tangents or with anything?
Any of the trig functions. Arc sine, arc cosine. It just means to the -1. We can use that. Cosecant. Fine. If you have that button. Now,
I had that button.
Now, there is a reciprocal function. For today, I'm not going to talk about it because we don't need them for right now.
Right.
What I want to make sure is that you know your trig functions and you know a few properties about them. Like for instance, one of the main things, if you were to square the sine function, whatever that answer is, and square the cosine function,
How is it equal to square?
you're gonna add them up and they're gonna make 1 every single time. When you square them, you add them together. Because basically what they are, they're decimals, and when you square them, you're actually making a triangle with a unit length of 1. That's the hypotenuse basically. It's the Pythagorean theorem applied to a unit triangle. Unit circle, I should say. The other formula that some people tend to forget is this one. This is a big one. This is one that we'll probably use more or less most of the year. In this class anyway. This is used a lot in Calc 1. That sine divided by cosine is actually tangent. It's the same answer. We do a lot of replacements with those. That's one of the trig identities I have you memorize in pre-calc. It was on your property sheets. If we ever have to get back to the property sheets, I'll print out new ones. I don't think we'll need them for the most part. There's not a lot we have to cover
I
yet.
still have mine.
Yeah, most people do.
Most people do,
That's
okay.
a hasty
Just Nicole.
generalization.
Now,
That's
okay. The last thing I want to cover before we get to story problems, the graphs of these things. Other than looking at a picture and picking out how to find a missing wall or missing angle, because if I was missing one of these walls and I had an angle, let's say this angle here was, say this angle was 75 degrees. Say this is 75. If I needed to find the hypotenuse, you could still do the trig function as long as it's a right triangle, and you could do one of the trig functions that actually has hypotenuse in it and actually solve it. So, this is the one that people tend to get wrong because they have the number on the wrong side. So, I'm going to use sine. Sine of 75 is opposite over hypotenuse. If I were to solve for x, since x is on the bottom, you have to multiply it across. You get 6.6, and then the last step is to take this number and divide it over. Okay, so you divide it over. And whatever those numbers are, 6.6 divided by sine of 75, whatever that number is, that's the wall length.
6.8.
6.8, okay, about 7. Alright, so that's the idea, that you can solve. The most common mistake is that one. The x on the bottom, you can't just switch, you actually have to multiply it across, divide. Questions with trig functions? Okay, good, let's get to the graphs, or the story time I should say. Alright, so this is my last example of the day. So, story prompt.
Story time. Who's it?
We're gonna put this Hurricane Florence in the.
It.
We don't really have statistics on it.
It's got 160 mile an hour wind.
It's gonna be a category 5.
Is it?
No.
Is that?
Yes, it is.
And CNN student news said
Okay.
category 4.
I don't know if I spelled it right.
They said it's gonna be a category
Okay.
5.
All right. Hey,
That's hasty. You can't predict this
Okay.
storm. You can't predict the weather.
let's say. Hey, let's say on the coast in South Carolina, the average water at the coast, like where you're in like the waist deep water, is 5 feet. That's the average where the water sits. So, that's the average when you're out kind of out in the ocean in that general area where the swimming is. Okay. Now the water fluctuates depending on the actual like it depends on basically the moon and the lunar eclipse and when the moon is in certain phases, the tide levels rise and fall. Let's say that at a peak during the day, at a peak, the water level rises to 9.9 feet. In that, so it goes up the beach quite a bit further. But depth-wise, out in the ocean, it goes to about 9 feet in that normal area. At the lowest level, where there's basically like a new moon, or during the day, it could be just a certain point during the day where the moon's on the opposite side of the earth. The lowest level of the tide might be, let's say it's 0.8 feet. So it almost shrinks to 1 foot when the water's being pulled the opposite direction. So the tides can rise and fall within hours. Typically it's usually over days, but we'll say it's over an hour, especially with this hurricane coming in. So the idea is that we can actually represent the tides with a trig function, because the trig functions are actually used for water and sound, because they follow that same pattern. So what we're going to do is we're just going to pick one of the trig functions. I'm going to pick sine. Let's pick the sine function. And we're going to talk about how to apply numbers to a trig function, because these are the wave graphs. Okay? So what I'd like you to do right now is draw a normal sine graph on your paper. So here's what a normal sine graph looks like. 0 to 1, sorry, negative 1 to 1. And then the 4 hash marks going across.
And then you
2
divide
pi over 2,
Do you actually love
3
this?
pi over 2.
I
Alright,
kinda did.
I would like you to draw this out on your notes right now.
Why? I'm just kidding.
Okay, draw that out. Now this is only one period length, one cycle length. Coffee.
No, why did I do it that way?
Okay,
No, that's not what I did.
No, I promised not to do that
You're probably taking a whole lot extra work.
Sure.
What do you mean?
I can't believe you're gonna be there on that day. Okay.
Are you gonna tag?
So we've been playing tag over here now.
alright. So now, we're gonna apply the trig functions to this item. Now, if the average water level isn't 0, right? On this picture, 0 is the middle. That's the average. We're not at that. So the idea is that we're gonna be at whatever the average number is. So we're gonna be shifting my graph up to match the water level at average is 5. So this is how the graph would be manipulated. So, this accounts for the water level being at a normal height of 5 feet normally. Then it will go up and down from there. So, how we account for the peak and the lowest point, the peak and the valley, I guess, you have to find the average between them. Because really what I need to know is basically, wherever that 5 foot marker is, I need to know how far above that and below that I'm actually going to go, so that I can draw my drawing around it. Now, this is where you use the peak and the lowest point. What we do is we find the difference between them. So that's 9.9 minus 0.8, which is 9.1. That's the difference. And then you divide it by 2. And dividing it by 2, why we would do that, that's going to separate it out to the top half and the bottom half. Okay, what is that, 4.05, something like that?
That's a good question.
Isn't it
You were
4.5?
close. Try it again.
4.55?
4.5.
4.55?
4.65.
Okay, that number, 4.55 sine of theta. This number that's in front of the sine affects your peak and valley. We're gonna go almost 4.5 feet above, 4.5 feet below the average. That will get us to our peak and to our valley, basically. I don't even know if we did that.
And then show if the storm surge comes
Wait,
in.
how does-
I'm dividing. I don't know.
Mr. Ward, you have to throw a storm surge in there. You
Mr.
get
Ward,
20
go with
feet.
the 20-foot storm surge and just spike it up there.
Spike it up there, alright.
No, they said it would be a 20-foot storm surge.
Seriously?
Yes.
Yeah.
They said anything above 12
My uncle
causes
was up there,
casualties.
that's why I'm kinda watching.
Wait, is he evacuated?
Yeah, I think they went
It's
all the way
mandatory
to,
evacuation.
I think they went up to New York at the time, because his son lives up in New York and he's a day trader.
Where does he live at?
Lives in Manhattan, lives a day trader, so.
Ooh.
Alright, so,
It's a
anyway.
what?
He doesn't trade it.
It's stressful.
So,
Alright,
like, when
anyway,
there's-
so, the idea is that 4.55 accounts for the difference in wave height. And now what we're gonna do now, the next thing is, we have to count for the time of the day. Let's say that the tide rises and falls in a 12-hour period.
Curlew on the beach calls.
Alright, now,
Henry Wadsworth fellow.
okay, the next number I'm gonna count for is the actual time of the day. If the cycle is a 12-hour period, so this is 12 hours between the peak and valley. That's what that is, that's the frequency. So what you do, by normal, it would go out to 2 pi. We're gonna take 2 pi, that's what we normally hit, and divide by 12 hours. So that number is gonna go here. So what we're gonna put in front of this theta
What does this symbolize?
is this gonna represent the period length. So it's going from from beginning to end. So in a 12-hour period, it goes from tallest to lowest,
Like a poem.
right? Like what?
A poem.
A poem.
Poem.
Henry
Henry
Wadsworth.
Wadsworth Longfellow's poem, The
The tide rises, the tide falls.
Sure.
The curlew. What does it mean?
I'm not cultured like that.
Like
Alright,
time?
Alright, normally we're going to go out to 2 pi, but we need to divide this by 12, and this will give me the number that's going to be in front of the theta, that angle that I'm, so what this will simplify into is pi over 6.
Wait, why is it 12
That number goes here.
hours?
This will account for the 12-hour period. And what this is going to put on my graph, it'll manipulate the graph to be this. Where this is 5 now, that's the middle. This is my dashed line. 0's way down here. I can go 4.5 down to get to the point, is that 0.8 I guess, in that general range. If I go 4.55 down, that'll get me to that kind of the lowest peak. 4.55 up will get me to the highest point, 1, 2, 3, 4, and a little bit extra. And then the idea is that the hash mark all the way up here is the 2 pi over 12, which is pi over 6.
The lowest peak?
We're going down.
The lowest point, sorry, did I say peak?
Yes.
Point.
It's
Now,
okay, it's good.
if we divide this by 2, that's pi over 12. Divide by 2 again, pi over 24. And if we,
I have 6 pages of
That's a 12.
from last year.
Multiply that by 3.
and then we multiply that by 3, which is going to be pi over 8. Because again, when you multiply by 3, the 3 goes to the top, and you simplify it with the 24. And then this is the idea. This is what the graph will look like.
Beautiful.
That's the graph, and that represents the wave of this particular storm surge, I guess. Now, obviously, ours goes to 20 feet, if that's what they're predicting. And the lowest point would potentially be 0. It'll drain out the water. That'll happen in the first couple hours of that storm. When it comes into shore, all the water's drained out for hundreds of feet from the shore.
Is that what actually happened?
Yeah, that's how they know, in islands, when you're about to get a massive hurricane or a storm or like a tsunami, all the water drains out. And then it starts to boil up, because what's happening is that it's basically like collecting all the water in its vortex as it spins, and then it's gonna push it forward. So then you'll see that wall basically of water coming out.
So what happens if you get a storm surge?
On a little island, was the island typically covered in water?
I mean, yeah, and especially in that type of thing, it'll go 20 feet above sea level. So if that island's sitting at 0, Yeah, it's gonna be 20 feet above ground, and it will just keep going because the water behind it is still pushing. So out in the ocean, it just goes all the way across the island. So it kind of levels things. It happened in Indonesia a couple of years ago where it just pushes water as far as the storm keeps surging. So like it'll keep pushing water inland, like this hurricane, until the storm loses its strength and it won't keep filling water from the ocean. That's what they're so dangerous about. They told my uncle when he had to evacuate from his house that they have to go hundreds of miles inland. Hundreds of miles. Like for us, like putting that in consideration, that's like here to Des Moines or further, you have to go in because there will be water 20 feet high. That's silly. That's hundreds of miles. I can't even fathom, like, there's water, like standing water from here all the way to Des Moines because of a storm.
You try it.
So,
But they said the storm is really slow, so it's gonna
like, once it hits land, it's like 3 miles an hour. It just crawls. But the winds are 150 miles an
So
hour.
it could potentially reach Iowa if they kept pushing that far?
Yeah.
It could.
I mean, not the water.
We might
it would
get 20
rain,
feet of water.
but we wouldn't have water from the ocean because at some point you just
Jared,
can't
the water from
hear
the
that
ocean
mass.
is all
just like
gonna
a
be Des
long
Moines.
Oh my gosh,
Alright.
it's really
Here's
cute.
Des Moines.
Times, like,
That's it.
the